Faik ada tak Faik? Faik Idlan.
Ada, Doktor.
Ya, Faik, baca Faik. Chapter 3.
Sekejap. Yang Doktor bagi tunjuk ni. Introduction to Estimation. In the field of statistical inference consists of those methods used to make decisions or to draw conclusions about a population. These methods utilize the information contained in a random sample from population in drawing conclusions. Statistical inference may be divided into two major areas: parameter estimation and hypothesis testing. Lepas tu, Doktor tak nampak lagi. In parameter estimation, the sample statistic is calculated from the sample data and the population parameter is inferred or estimated from the sample statistic. This statistical estimation of the population parameter can be divided into two types: point estimation and interval estimation. Okay, so 3.2 point estimation. The objective of point estimation is to obtain a single number from the sample which will represent the unknown value of the population parameter. Population parameters, population mean, variance, etc. are estimated from the corresponding sample statistic, sample mean, variance, etc. At point estimate of some population parameter theta is a single numerical value theta apa ni of statistic theta. For example, the value x bar computed from a sample of size n is point estimate of the population parameter mu. Similarity, p equals to x over n is a point estimate of the true proportion p. The following display summarize the relationships between the unknown parameters and their typical associated statistic and point estimates. Non-parameter theta mu, statistic x bar equals to 1 over n, summation of xi. Point estimate x bar. Variance s squared equals to 1 over n minus 1 summation bracket xi minus x bar close bracket square s squared p equals to x over n mu1 minus mu2 x bar 1 minus x bar 2 equals to 1 over n1 summation of x 1i minus 1 over n2 summation x2i. P1 minus P2 equals to x1 over n1 minus x2 over n2. For example, the sample mean x bar is an estimator for the population mean mu. For example, let's say you wanted to know the average height of children in a certain certain school with population of 1,000 students. You take a sample of 30 children, measure them and find that the mean height is 150 centimeters. This is your sample mean, the estimator. You use the sample mean to estimate that the population mean you estimate is about 150 centimeters.
Okay, understand for this one. Okay, we'll go to chapter 3. Chapter 3 is about estimation. Estimation anggaran. We want to estimate anggaran. Okay, in statistics, in the field of statistics inference, consists of those methods used to make decisions or draw conclusions about the population. Okay, we want to make a conclusion based on sample. Okay, I think this one. Okay, we had this one is population. Population. Okay, population. Okay, about this one estimation in statistics, we interest about mu. What is the symbol mu? What is symbol mu? Mu. What is the symbol mu? What is the mu?
Mean.
Mean. Okay. In statistics, we like interest about mean, variance. I already teach about P. P is the proportion. This one proportion. Okay. Normally we just consider 3 for this one. And okay, in statistics, normally population about mean or variance of P. We unknowns. This one unknowns. So we unknown kita tak tahu. We don't know. For example, the weight, student UTM, we don't know about what is the mean of student UTM. Weight student UTM, just student UTM, it is about 15,000. It is very big sample, and we don't know what is the value this year. Okay, in statistics, we want we just using the sample. We just using the sample to make a conclusion about the population. For example, this one. Okay, estimation, if you see this one, we have two, point estimate and interval. Interval. Okay, point estimate, for example, this one, we don't know about the variance. This one we don't know. Okay, we can estimate the mean. Okay, for example, in this class is about 60 students. In this class is about 60 students. Okay, from the student, I can calculate their mean. For example, I can get the mean is about 62 kilogram. Okay, from here, we can make conclusion. We can make conclusion that the weight student UTM is about 62 kilograms. It is 62 kilograms. Okay, this one is just one single value. One single value. We call this one is point estimate. Point estimate. Understand for this one? Faham tak ni? Maksud dia point estimate maksud dia just one value, just one satu nilai je. Satu nilai. We don't know. Normally in population we don't know the value of mean. Same which we don't know about the variance. Variance with student UTM pun we don't know the value or proper P. For this one, this is the formula. The formula. Okay, for this one, the mu we don't know. We can estimate from the sample. This is the point estimate, just one value. Okay, same with this one. If we don't know the value of this one is variant population, which don't know here, we can calculate using this formula. Using sample. This one is same. This one is a variance population. Okay, we can estimate using variance sample. From sample, we can make a conclusion about variance population. Okay, same about the proportion. I think you know about proportion. I already teach about, for example, defect, proportion of defects. And this one we can test based on the sample. Okay, for different, it is the formula of different. Mean 1 minus mean 2, and this one P1 minus P2. Okay, understand? Faham tak ni benda ni? Jadi dalam kalau tengok ni biasanya dalam population memang kita tak tahu nilai mean, variance ataupun P. Jadi kita boleh anggarkan berdasarkan sampel saja. Kalau if you see this one just one value, we call this one is the point estimate. Just point estimate. And satu lagi we call this one is interval estimation. What means interval estimation? Interval it is mean selang dia selang this one. For example, we can set the weight student UTM is from 50 to 70. 50 to 70 it is interval estimate dalam bentuk selang. Interval. Dipaham maksud dia? Faham kalau interval dia. Kalau one value just 62, kalau interval is from 50 to 70. Okay, in statistic, interval we have the confidence, confident interval, confident belief. Kita percaya percentage. Okay, for example, I believe that the way student U10 is from 55 until 75. Okay, how percentage you believe that the student is between 55 until 75? Berapa keyakinan awak percaya dia? Nilai dia 55 hingga 75. Okey, adakah berapa awak percaya keyakinan awak ni? Apa ni? Okey, Muhammad Atin. Berapa persen you believe that the student UTM is from, the weight is from 55 until 75? Agak berapa persen awak percaya ni?
50% atau
50% je,
tak sure.
Sikit je percaya. 50%. Okay. Muhammad Alif believe percaya that the student UTM between 55 until 75. Okay, Saudah agak berapa persen awak percaya? Student 55 hingga 75. Saudah ada tak ni? Saudah tak ada kan? Tidur.
Ada.
Okay, berapa persentage? Berapa persentage awak percaya? Berapa peratus awak percaya bahawa student UTN berat dia antara 55 hingga 75? Ini percaya tak kisah berapa persen awak tak kisah, penting awak percaya. Tak tahu tak usah ada. Awak teka je berapa persen je. Okey, kalau the range saya tu besarkan become this. For example, from 55 until 80. Berapa keyakinan dia? What is the percentage? Agak semakin menurun atau semakin bertambah? Percaya. Okey, soalan agak berapa persen? Percaya.
Semakin tambah.
Tambah. Berapa persen agak ni? 45 until 80. Berapa agak ni? 60%. 60% je? Friend, kumat. Sikit je nampak student dia student yang paling banyak dekat mana range ni? Ini dah tinggi sepatutnya, tinggi 45 until 80. Itu almost 90%, okay, 80%. Okay. If I to expand again, this one 40 until 90. Agak persen ni tambah tak tambah? Sebab nampak pelajar gebuk Okay, ni agak berapa persen? What is the percentage? 40 until 90. Okay, dah naik 90. Jadi sudah UTM antara berapa ni? 30 until 100. Berapa percentage? 100% mungkin ada 90%. Mungkin ada student yang lebih berat daripada 100 ada tak ramai itu satu ataupun dua orang. Okay, in statistic okay, like this one we have two method to estimate this one. Just one value we call this one is point estimate, and the second this one have interval and percentage, it is the interval estimation. Okay, I think this is okay. Okay, this is the formula. If we don't know the value of population new, we can estimate using sample, using the formula S bar. Okay, the number two, if we don't know the variance is unknown, we can estimate using sample from sample S square. Okay, same with this one is proportion. Proportion, we can using proportion is S divided by N. Okay, this is for to be different for different mean 1 minus mean 2. It is same mean 1 minus mean 2, it is equal as 1 bar minus as 2 bar. We estimate using the data. Okay, we go to this one interval estimate for single mean. Okay, we have three formula this one. It is the formula is related with chapter 2 estimation. Chapter 2 is sampling. We look the formula number 1. Formula number 1. If variance, this one is called is variance. Variance population. Variance population on or this one sigma is equal. Sigma is a standard deviation. Standard deviation population. Standard population nonce. For any n. The z is equal s bar minus mu divided by sigma divided square root n. From here we want to find what is the value mu. What is the value mu? Look here. From here, what is the value mu? Apa formula mu? Pada rumus ni, based on this formula, what is the value mu? Mu is this equal. And those here, mu is this equal s bar. After that. What is S bar after that?
Plus Z times sigma over
n. From this formula we can get the formula here. We can modify from here. We can modify plus with put plus minus, and this one Z is we call this one is Z alpha divided by 2. This is the formula. This is the formula. Formula for 1 minus alpha percentage confidence interval for mu. This is the formula. It's a formula. The number 1 it is equal s plus z alpha divided by 2 sigma divided by n. These two. This is the formula. If you see the formula like this one, the graph for this one is like this one. It is normal distribution. We divide by 2. This one is 1 minus alpha, and this one is alpha divided by 2. This one is alpha divided by 2. This one is z alpha divided by 2. This one minus z alpha divided by 2. This is the confidence interval for this one formula. This one, just remember if the question variance or standard deviation is given, we can using this formula, the confidence interval. The confidence interval we can write like this one. Sambung using this one. Mu is equal. From S bar minus Z alpha divided by 2 sigma divided square root n. This one S bar plus Z alpha divided by 2 sigma divided by square root n. It is the formula. Normally we just using this formula, so easy. This same for this one. Mu is between this formula. This one it is the number 1 formula. We have 3 formula. The number 2. The number 1 if variance or standard deviation is non. For this one non. And this one is for non. If non, it is any n. The number 2. If variance this one unknown. Then n greater than 30, n greater or equal 30. Right? We can using the formula same. Formula same, just this one s bar minus mu. For this one s divided by n. Because this one is unknown. Because we don't know the value this one. We just using sample from sample. Ci, the formula is almost same. This one. Ci for mu. Formula is same. Just change variance with s. Ci Ci for mu it is equal, formula same, S bar plus minus Z alpha divided by 2 as okay, for this one S divided by N. The formula is same, just change this one. If you see this one is a sigma, this one S, because variance, we don't know the value of variance. Okay, the number 3. Okay, the number 3, we have 3 formula. Okay, if this one same, unknown, okay, the variance is unknowns, and N smaller than 30. We can using the new formula from you. This one is we can using the T test. T. The formula same. T test S minus mu divided by S divided square root N. Okay, from here we can get the formula Ci for mu it is equal. Okay, the formula is same. This one S plus this. This one if this one T, we must using this one is T alpha divided by 2 S divided by N. We have the symbol V. But for this one V have V. Okay, V is the purpose of V is used to for find the table from the table, to look the value from the table. Okay, V it is equal N minus 1. V is equal N minus 1. Okay, understand from here we have 3 formula. If you want to find the confidence interval for mu, we have 3 formula. The number 1, if variance or sigma non, maksudnya kita nilai dia dah beri. Kita tahu, we know the value of variance and standard deviation. We can using the formula mu is equal S bar plus minus Z alpha divided by 2. Sigma divided by square root N. Okay, the number 2, if this one is unknown, kita tak tahu nilai population, we can, and N greater than 30, we can using the formula same. Just change sigma with S. Okay, the formula like this one, formula same. Okay, the number 3, if this one variance unknown and N less than 30, we can using the new formula using T distribution. Okay, the formula, if you see the formula is almost same, just change Z with T. Okay, we look how to use this formula. We have 3 formula. Okay, try. Okay, this is the note. How the note? I just summarize. Okay, this one is the number 1. For sigma is given. The number 2 is for sigma not given. And greater than 30. Okay, this one is the formula. Okay, we look this example. This one. Okay, baik, baca balik, baik. Okay, baca example 1. Baik, try read example 1. Baik, tak ada. Dah keluar baik. Okay, Amir Irsad ada, Amir Irsad. Amir.
Yeah.
Okay, Amir baca, Amir. Example 1.
Example 1. Suppose a student measuring the boiling temperature of a certain liquid observe the readings in degrees Celsius, 105, 100.5, 102.5, 101.7, 103.1, 100.9, 100.5, and 102.2 on 6 different samples of the liquid. A. Find the best estimate of mu and variance. Mean and variance. B. If he knows that the standard deviation for this procedure is 0.49 degrees, is the interval estimation for the population mean. 1. At a 95% confidence level. 2. At a 90% confidence level.
Okay, dah ya. Okay, look here. Okay, example this one. Suppose a student measuring the boiling temperature of certain liquid. Observe that the reading in degree Celsius. Okay, sampai ada 6 different sample of liquid. Find the best estimate of mu and variance. Okay, look here the number 1. Find the best estimate. Okay, what is the best estimate for mu for this one? The best estimate for mu, this one kita lihat yang tajuk pertama dulu kita lihat okay, this one. Tengok dia punya nota this one. Okay, this one. The best estimate for mu is S bar. Kalau soalan ni what is the best estimate for mu, kita kena cari S bar. What is the value S bar? S sample. Same with this one, what is the value best estimate for variance adalah S kuasa 2. Sebab kita tak tahu dalam kes ni we don't know the value of temperature, we just take from the sample. From the sample. Okay, try calculate what is the value this one. Okay, try using calculator, what is the value there? What is the value S bar? S bar. Okay, find S bar. S bar is mean. Okay, try calculate this one. We have 6 data, just 6 data. We want to find what is the best estimate. Okay. Okay, berapa dapat nilai dia? Berapa dapat nilai? Try calculate berapa dapat nilai dia?
One
Okay, 101.8. This one. Okay, okay. What is the value sigma? This one sigma. Sigma. Now the best estimate is S. Okay, try S using calculator. Just n plus. This one just n plus. Using calculator n plus. What is WS? And using sheet 3, sheet 3. Okay, mode 3, statistic, 1 variable, masuk data 102.5. 101.7, 103.1, 100.9, 1. Okay, what is the value? Okay, N 1. Okay, 0.98. Okay. Okay, now we get the answer S 0.9847. And make sure you get the answer 9847. Okay, this one the best estimate for mu is S bar, for S bar. this one, and the best estimate for sigma is S is equal this one. And you must mention soalan ni kena nyatakan this one it is not equal. This one mu this one is not equal this one. You must mention the best estimate for mu is equal S bar. Same with this one, the best estimate for variance is S. It is equal 0.89847. And you cannot mention the sigma. You cannot write this one as. Okay, if you write like this one, it is wrong. This is wrong because sigma is not equal this one. S is just best estimate. Anggaran saja, just estimate. Or you can write, you can put head. If you write head is okay. Head is mean estimate, not the real value of sigma. This just estimate value of sigma. Okay, you can write like this one, and just put head like this one, or you can write this one using sentences. The best estimate of the estimate for sigma is S is equal 0.9847. Okay. Okay, number one is okay. Okay, the number two, looks the number two. Okay, if he know the standard deviation for the process is 0.49 degree, what is the interval estimate for the population mean? Okay, which formula we want to use? We want to find 95% confidence interval. Rumus mana nak gunakan? We have three formula. We have three formula. This one number one. This one number one. If sigma is known or sigma is known, the number two is unknown and greater than 30. And number three, n less than 30. This one is unknown. Whereas is unknown. Okay, for this question. Okay, the number B. Which formula? Number one or number two? Okay, number one, Muhammad Daniel, number one. Because this one is known, if he known the standard deviation, it is sigma is given, for this one, sigma is given. Sigma is given is 0.1449. Okay, we take the information, S bar is from population, we get this one, 1.8. Okay, sigma is given 0.49 and n for this one, n is just 6. Okay, we want to find what is the 95% confidence interval. Okay, 95% like this one, 1 minus this one. Okay, like this one. This one is 95%. 95%. Okay, it is equal 1 minus lambda. 1 minus lambda is 0. Okay, what is the value alpha? What is the value alpha? Alpha divided by 2. Alpha divided by 2. Okay, from here, what is the value alpha? Okay, from here, what is the value alpha? Berapa nilai alpha? Tengok 1 minus alpha, it is equal 0.95. Okay, alpha, it is equal 0.05. Okay, from this one is alpha divided by 2. Alpha divided by 2, it is equal 0.025. Okay, look, this one is formula number one. Formula number one, we just using this Z alpha divided by 2. This one is minus 0.025. Okay, looks from the table, what is the value? And this one, Z looks from the table is alpha is 0.025. Berapa nilai dia? Tengok alpha 0.05 from the table. Berapa nilai dia Z? Tengok alpha tengok table yang pertama saya kasih nilai Z. Alpha 0.025, what is the value Z alpha? Okay, berapa nilai dia? Okay, okay. Good, go, dapat go. This one is 1.5 0.96. This one is negative. We have to value. Okay, from here we can calculate. If you see the formula number one is 95% CI. CI is confident interval. CI ni I just put CI. Gunakan singkatan. Okay, for mu it is equal. Kita lihat the formula S bar plus minus Z alpha divided by 2 sigma divided by square root and then this formula. Okay, if you see all value we already given this one, we just put okay, S bar is 1 plus minus Z alpha is 1.96 sigma 0.49 divided by square root 6. Okay, try calculate. Okay, yang depan ni smallest this one is smallest and the belakang is the largest Yang kecil depan. Berapa nilai dia? Okay, and yang depan we can get was 101.41 448. Okay. Okay, belakang apa dapat? Okay, we 102.192. Okay, 192. Okay, we can set we believe that the measuring the boiling temperature is between 101 until 102. This one boiling. We believe 95% nilai dia berada dalam. Okay, try 95%. Okay, number 2. This one is number 1. Number 1 is 95%. If 90%, just 90%. What is the value? Okay, this one is number 1. Okay, number 2. Number 2 is for 90%. Okay, it is equal. Berapa nilai dia? Okay, what is the value? Okay, for this one, 95%. What is the value? 95%. Okay, 95%, 90%, 1 minus alpha, it is equal 90%, 90%, 0.9. Okay, from here we can get alpha is 0.1. Alpha must divide by 2, we can get 0.05. Okay, what is the value Z? 0.05. From the table, alpha 0.05, what is the value? Okay, 1.6449. Okay, try calculate the formula same, just change the alpha. Okay. Okay, it is equal 101.8 plus minus the alpha is 1.4669. 0.49 divided by square root 6. Try calculate it. Berapa the lowest berapa ni? Okay, the lowest is 1 or tengok dia punya 1.47. Okay, satu lagi. Okay, 102.13. Mana lebih luas mana lebih lebar Which one? The number 1 or number 2 lebih lebar, lebih wide, more wide If you see the number 1 more wide compare with the number 2 kalau tengok dia punya selang is more lebih luas lebih jarak lebih tinggi when we compare this one. Okay, number 2 is not too wide compare with the number 1. Okay, this one is okay. Try okay, number 2 the number 2. Okay, the number 2, if we are known the standard deviation. For example, this one we don't know the value of sigma. Sigma not given for this one. We don't know this one. Whereas and this one is unknown. Tak diberi we don't know. Okay, from here we can using from the sample. We just take from the sample. Okay, the sample. Okay, the sample S is 0.984. Okay, just take from the sample. Okay, and N is 6. S bar same. S bar is same 1.8 and S from here is equal 0.984. S is 0. Okay, 7. Okay, which formula we want? Okay, for this one, which formula we have? N is 6. The variance is unknown. And which formula? Number 1, number 2, number 3. We have 3 formula. Number 1, number 2, or number 3. Okay, number 3. Because why number 3? Because n less than 30. Number 3, we must using t distribution. You must using t distribution. Okay, for this one, 95%. 95%. 1 minus alpha is 0.95%. Okay, we consider number 1. 1 minus alpha is 0.5. Alpha is 0.05 and alpha divided by 2 is 0.025. Okay, for this one we must using the formula number 3. Number 3 it is t distribution. Okay, V it is equal n minus 1. It is equal n minus 1. It is equal n is 6. We can get 5. Okay, look from the t table. T distribution. T 0.025. V is 5. Okay, looks from the table. V is equal to alpha is 0.05, 0.025, and V is 5. What is the value for? Okay, looks alpha this one and V is this one. The new table, T distribution. Okay, the last table I already given for looks the was half, but looks alpha. The first looks the alpha. Alpha is 0.025. 0.025. After that, looks V is equal 5. Okay, what is the value? Okay, 2.571. Okay, that's okay. We can get T is 2.571. Okay, after we get this one, we can put the value into the formula. 95% Ti on mu, it is equal S bar plus minus T. For this one, T alpha per 2 B S divided by N. Okay, just put the value. S bar is already given 101.8 plus minus T S is equal divide by square root n, n is 6. Okay, try calculate berapa dapat. Okey, berapa dapat? Okey, the value. Okay, dah dapat. Okay, we had the value is the confidence interval is okay from 100.83 until 102.83. Okay, okay. Try number 2. Try number 2. This one. Try number 2. What is the value? Number 2 for 90%. This one 95. This one 90. Oh,
Excuse me, doktor. Saya tak faham lah part yang T, yang part yang nak cari T tu.
T, kenapa T tak faham? Tengok from table lah, tengok T tu. Tengok ni salah. T77. Okey, tengok alpha dulu. Tengok T tu buku surat page 35 tengok table 35, besar 35. Jumpa tak?
Oh.
Jumpa table besar 35.
Jumpa.
Tu tengok situ dah. Tengok lepas tu mula tengok alpha dulu. Lepas tu dah dapat nilai alpha 0.05, lepas tu tengok D5. Nanti kita
Okey. Terima kasih doktor.
Okey. Okay, ni try 95%. 95%. Okay, cara sama we just using this the information the given the information same this one same. The difference is alpha. Okay, 95%. What is the value alpha? Alpha for this one 1 minus alpha it is equal 0.9. Alpha from here alpha is 0.1. Alpha divided by 2 is 0.05. Okay, this one 0.05. What is okay, looks from the table what is the value alpha? Tengok alpha 0.05 and D is equal 5. Berapa nilai Z? 0.0 ZT. Look from there. Okay, from here still same using T distribution. Okay, T it is equal T 0.05, V is 5. Okay, berapa nilai dia from the table? 0.05, 5. Okay, 2.015. Okay, after that we can calculate confidence interval. Okay, using this formula we can get 95% CI on mu it is equal. Okay, try calculate using same formula. Okay, as by sudah ada nilai dia. Okey, berapa nilai? Jelas dia. Selang 100. Okey, 100.99 until okay 102.61. Okay. We can confident that the question is about boiling temperature. It is about we believe 95% that mean is from 100 until 102.1. Okay, this is two cases. The number case one is if variance is known. The second is the variance is unknown, and n less than 30. We using t distribution. Okay, try number 2. After that we stop. Okay, cuba number 2. Example 2. Okay, s bar is given, s square is given, and n pun is given. N is given, n is 12, and the second is n is 50. Okay, we have two questions. Okay, number one, right? Okay, go. Ziang go ada. Ziang hem go.
Ada.
Ziang go. Okay, number 1. Okay, the second, Firdaus ada Firdaus Aiman.
Ada doktor.
Okay, try number 2. Okay, yang lain itu dah. Try yang lain tunggu dulu lah. .62. Okay, from here, okay, go using t distribution. Alpha 0.1. Okay, alpha divided by 2 is 0.05. Okay, t 0.05. V is 11. It is equal 1.5. Okay, just using formula. 95%. Ci for mu, it is equal s bar plus minus t v s divided by square root n. Okay, from here we can get the answer is 3239.03 until 31.81. It's okay. Okay, this one is okay. Okay, the number 2. Okay, number 2, B. Okay, number B using Z distribution because n greater than 50. Okay, alpha same. Alpha 0.1. 2 is 0.05. Z 0.05. It is equal. Right? Z. Okay, this one Z. 2.57758. Okay, from here we can get 95% Ci on mu. It is equal using Z s bar plus minus Z alpha divided by 2 S divided square root n. Okay, just put the value into formula. Okay, we can get the answer is 3243.9 until 3265.94. Okay, any question about this one? Okay, all our student is okay. Okay. Tak ada masalah okay, jadi tak ada masalah buat ni, kedua-dua betul Okay, we stop here, we stop until here, we continue tomorrow. Okay, class until